Okay, so if you look at this problem, first thing they tell us is that DE and BC bisect each other. Today you're going to see that we have segments that bisect each other, as well as we have angles that bisect each other, okay? The ones that we're doing in our notes today is more angle bisectors, so I wanted to show you a segment bisector one. So first I'm gonna just write down my given, and it would just be DE and BC. I usually use BIS for bisect, and then each other. Okay, and that is given. All right, now they say DE and BC bisect each other. Bisect means cut in half. So what that would mean is that these two pieces would be congruent and these two pieces would be congruent. So what I would say then is segment DG is congruent to segment GE. And in the same step, I could say that these two are congruent. So BG is congruent to GC. Okay, and that is definition of segment bisector. Okay, now, do you guys see anything else in that drawing that is congruent? Anything else here that's congruent that's not marked? Yep.
The angles,
Yep, which ones?
BGD and CGE,
Very good. And why are those two congruent?
vertical angles.
Vertical angles. So I can say angle BGD is congruent to angle EGC. And when it's vertical angles, it's called vertical angles theorem. Okay, now, do I have enough here to show those two triangles are congruent? I do, and by which one?
Side angles.
Side angle side. So what I would do there then is say triangle DGB is congruent to triangle EGC, and that is by side angle side. Okay, so that was just one from your assignment on Friday that I told you guys you could skip, that I just wanted to go over, or on Thursday, I guess it was. So today what we're gonna do is we're gonna learn two additional ways to show that triangles are congruent, and I already wrote them up here on the board. So last week we did side, 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 angle, side, angle, side, angle, and angle, angle, side are this week. Okay, that's what we're learning today. So the first one of those that we're gonna talk about is angle, side, angle. And with this, one of the things you have to be really careful about is your side has to be right in between the angles. Okay, so when you're doing this, the side has to be right in between the two angles. The side has to be right in between the two angles. And then what it is angle, side, angle. Okay? So if I go down here, we're gonna try to do a proof. So what we're gonna do here is copy down our given. L is the midpoint WE, and our WR is parallel to ED. Okay? So that is our given. Now, we can't do anything with the midpoint quite yet, but let's write the parallel arrows on those two lines, WR and ED, okay? Now, do you guys remember me saying last week that if you have a midpoint, you're going to always use midpoint theorem, okay? So what they're saying here is L is the midpoint of WE right here. What that tells us then is those two pieces are equal. It does not tell us that L is the midpoint of RD, so I can't mark that, just these two. So I'm gonna say segment WL is congruent to segment LE, okay? And that is by, what did we say? If you have a midpoint theorem. Okay. Now, when they give you that you have parallel lines, what that means is you're gonna use those at some point, okay? Last week I talked about if you're given parallel lines, 99.9%, if not 100% in this course, you're going to use what kind of angles? Alternate interior, okay? So that's one of the things that we can still use. Do you guys see an additional thing you can use here? Is there something else besides alternate interior angles that are congruent, Keandra? Vertical angles, very good. And in this proof, I don't want to say too much because once I teach all of today, you could do this proof two different ways. But for right now, we only know angle, side angles, so that's why I'm doing that step first. Now, do you guys all understand when you're writing these angles, you have to use 3 letters, okay? So I can say angle RLW is congruent to angle, and I could either say ELD or DLE. I'm gonna say ELD, okay? And when it's vertical angles, how do you say that again?
Vertical angles.
Yep, vertical angles theorem. Very good. All right. Now, right now, we know 3 different ways to show triangles are congruent. We know side, side, side. We know side, angle, side. And we know angle, side, angle. Okay? When you have angles involved, that tells you right there that it can't be side, side, side because we have angles involved, okay? We still have to use our parallel lines, and we talked about when you have parallel lines, you want to look for alternate interior angles, okay? Now here's the deal with this. When you have parallel lines, that means this angle is congruent to that angle, and it means this angle is congruent to this angle. Right now, we only know angle, side, angle, okay? So do you guys think, if I erase this, W and E, is the side in between the 2 angles? No. So what that tells us then is that is not the pair of angles that we're going to use. But now if I erase these 2 and I put W and E back there, now is the side in between the 2 angles? It is. So now these I can just say angle W is congruent to angle E. So let's do that. angle W is congruent to angle E. And that is because they're alternate interior angles. So do you guys remember it's alternate interior angles what? Theorem, very good. Now, once you get these, notice all of these have three things, okay? And we right now have three things. We never use arrows when we're coming up with these three. They all have to be congruent marks. What is this? This is a angle, side angle. So would you get that it's this one? Okay. So what I'm gonna do here is I'm gonna copy this down as our fifth step. So it's triangle WRL is congruent to triangle EDL. And like we said, it's angle, side, angle. Okay? Everybody good with that? All right, now let's look at this. I'm gonna write down the given. Okay. Now, if you guys look here, one of the things I can mark right away is this part here, angle PSQ. PSQ is this angle, and that is congruent to angle RSQ, which is right there. Okay, that I can mark right away. All right. Now, in that same problem, I have something that says I have a segment bisecting an angle. That means that segment is cutting the angle in half. So if QS bisects angle PQR, that tells us that this angle and that angle are going to be congruent because it cut those in half. Now here I have to use three letters again. So I am going to say angle PQS is congruent to angle RQS. And earlier we did one that was definition of segment bisector. Here we bisected an angle. So this is definition of an angle bisector. Okay. Now, does anyone see something else that we could mark? Something else that's congruent, Keandra? Reflexive property, very good. So I could say SQ is congruent to SQ. And that is reflexive property. Okay. Then, do I have enough to say that these two triangles are congruent? This is a what? Angle, side angle. And is that one of them we know right now? Yes. So I can go down and copy this down as our next step. So I can say triangle PQS is congruent to triangle RQS. And that is angle, side, angle. Okay. Now let's go down to example 3. And notice this one we're given 3 different things. Okay. So step 1, we're given that segment AB is congruent to segment CB. Angle A is congruent to angle C, and DB is congruent, oh no, bisects, sorry. DB bisects angle ABC. C, and step 1 is given. Okay, now we want to make sure everything is marked on our diagram. Notice they have that AB is congruent to BC, and they have that angle A is congruent to angle C. Now, some of you might look at this and say, I'm not going to use this right here. I'm going to say reflexive for this, okay? But think about this. I have side, side, side is one that I can use. I can use side, angle, side. And for right now, I can use angle, side, angle, okay? One thing that I tell kids all the time is we can't swear in math, okay? When you look at this, if you read this way, this is an angle, side, side. And if you look at that, that's AS. And so we can't do that, thankfully, so then you don't have to worry about it. If you did, they would call it side, side, angle. But that is not one that works. So if you ever get down and you think like, well, why didn't they just have us use like this reflexive property? Because that's something that's true there. But that doesn't give us one of these three, okay? If they ever tell you that you have an angle bisector, that means you're going to use it. And they're saying DB bisects angle ABC. So that means this is congruent to that. It bisects that angle. I have to use 3 letters there. So I'm gonna say angle ABD is congruent to, and you can name this angle either DBC or CBD. B just has to be in the middle. Okay? And that would be by definition of, and we bisected an angle, so it's angle bisected. Okay? Now, do we have 3 things? And do you guys get this is an angle, side, angle? And the side is in between the 2 angles, so shouldn't it be this one right here, right? But notice they don't have us proving that 2 triangles are congruent. What does that tell us? What did we learn last week that can happen sometimes where you don't CP, CTC? So you still have to show the 2 triangles are congruent, but then you're gonna have an extra step. Now, I was telling you guys last week, when I write the congruent statement, I usually, last week we went along sides, but if I have 2 angles, I'd use that. And notice this is an angle with 1 arc to 2 to none, so I'd call it triangle ABD is congruent to, and then I would do that same order here. I'd go from 1 arc to 2 to none, so it'd be CBD. That is not the only way you can write that, but that's what I do when I know 2 of the angles. I go from the angle with 1 arc to none, or 1 arc to 2 to none. And this should have been a triangle. And that was, like we said, angle, side, angle, okay? Now, we're to the point where we can bring down our proof statement, and that is AD is congruent to CD, and that is by CPCTC, okay? All right, we have 3 more. Okay, so we're gonna learn our last way to show 2 triangles are congruent. And in this one, it's angle, angle, side. In this one, your side is not included or not in between the two congruent angles. Okay? If it is in between, it's called angle side angle. If it's not in between, then you call it angle angle side. Okay? Now, when we do this, okay, we have side, 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 we have side, angle, side, we have angle, side, angle, and now we have angle, angle, side. When you guys go to do this, if you have two angles and a side, hopefully that would tell you right there that these two don't work, okay? These have two angles and a side, so you have a 50-50 chance of guessing it right. Know that angle side angle, the side has to be in between the two angles. If the side is not in between the two angles, then it's angle, angle, side. Okay? So we are gonna go ahead and try one of these. So we're gonna write down the given. Angle N is congruent to angle L, and JK is congruent to MK, and that is given. Okay? Now, those two things are both marked here. Do you guys see something else that we can do?
Vertical angles.
Vertical angles, very good. So I can mark this and this. I have to use 3 letters there. So I can say angle, and I could either say angle JKN or NKJ is congruent to angle LKM. And like you guys said, that's vertical angles theorem. Now, I just want to ask you guys this, just to make sure that you wouldn't make this mistake. Could I say this angle and this angle are congruent in the pink because of alternate interior angles? No, why not?
Because they are parallel.
They're not parallel. Very good. I just want to make sure you knew that. Now, do I have enough to say I have 3 things, right? I have 2 angles and a side. If it's angle side angle, the side has to be in between the 2 angles. If it's angle angle side, the side is not in between the 2 angles. Which one is this?
Angle angle side.
Very good. So we're gonna say that triangle JKN is congruent to triangle MKL by angle, angle, side. Okay, now let's go here and let's write down our given. We have segment DE is parallel to segment FG, and angle E is congruent to angle G, and that is given. All right. Now, if you notice, DE and FG are parallel, and that's marked here. And angle E and angle G are congruent, and that's marked. Okay, does anyone see something else I could say? Let's see.
Alternate interior.
Alternate interior angles. When you see parallel lines, you need to think of alternate interior, and that would be this one and this one, okay? I have to use 3 letters there. So I'm gonna say angle EDF is congruent to angle GFD, or I could say DFG, whichever way I want to say that. F for that bottom one would have to be in the middle. And that is because of alternate interior angles. So I'd say alternate interior angles what?
Theorem.
Theorem. Very good. Okay. Now I have 2 angles. Do I see anything else? Lexi?
Reflexive.
Reflexive property, very good. So this side is congruent to itself. So I can say segment DF is congruent to segment DF, and that is by reflexive property. Now, I have three things. I have two angles and a side. When you have two angles and a side, that means it's angle side angle or angle angle side. Which one is this?
Angle side.
And do you get it? Because this side is not in between the two angles, that's why. So let's go and write that down. So we're gonna say triangle DFG is congruent to triangle FDE, and that is by angle, angle, side. Okay. All right, last one. So there are going to be times, now that we know all four, that you can do some proofs with using angle, angle, side, or angle, side, angle, depending on what you pick. It's not all the time. And usually, like if it's on my key, I would say this one can be done more than one way. So it's not all the time, okay? But this happens to be one that you can. So let's go ahead and write down our given. S is the midpoint of QT, and QR is parallel to TU. Okay, so the parallel part is marked. If we see we have a midpoint, that tells us we're going to use what? Midpoint theorem. Okay, so let's do that. It says S is the midpoint of QT. That means QS is congruent to ST. So QS is congruent to ST. All right, and that is midpoint theorem. All right, now here's where you can go different ways with this proof, okay? Just depending on what two angles you show are congruent is going to change whether it's angle, angle, side, or angle, side, angle. So somebody just tell me, what's one thing you see that we could mark?
Alternate interior angles.
Okay, and do you guys get that with the alternate interior angles, you have two sets? You have Q and T, and you have R and U, okay? So let's go down and write that. Angle Q is congruent to angle T. And then we also had that angle R and U are alternate interior. So that step would be alternate interior angles theorem. Okay? So if we, bless you, if we look back, we have three things now, right? And we have two angles and a side. Is that angle side angle or angle angle side?
Angle side.
Very good. So what I can do then is bring that proof statement down. So I can say triangle QSR is congruent to triangle TSU. And what we did is we used angle, angle, side. Let me just, for 2 seconds, show you how this could have been different, okay? Let's say somebody at first showed vertical angles, and they said, this angle is congruent to that angle by vertical angles. That's true, right? and then they went to do their alternate interior. If they had to do one alternate interior at least, and if they used this one, okay, Q and T, what would that be by?
Angle, side, angle.
Yes, angle, side angle. If instead they did the other two and did R and U, then what would that be by?
Angle, angle, side.
Angle, angle, side. Do you guys get that? So there's really 3 different ways to do this one. Just kind of depends on what ones you choose. No one's wrong. I would know that there's more than one way. You don't have to worry about that. Okay? And then here is your assignment. Right here. Okay? And I actually have it. Let me try to find it. This is section 4, day 1. I'll try to see if I have a key